Hey there guys, Sophia here from the Authenticity Integrity Group. In this video, we are going to be looking at the Ohm's Law to understand how it works and how to use it. There are also two problem sets at the end of this video for you to test your knowledge and see if you can solve them. Here are the following objectives. By the end of this video, you should be able to describe the Ohm's Law theory as well as solve circuit problems, both in series and in parallel. So what is the Ohm's Law? The Ohm's Law is the relationship between voltage, current, and resistance and how they relate to each other. It was developed by a German physicist named George Ohm, and he stated that the electrical current flowing through a metallic wire is directly proportional to the potential difference across its ends, provided that its temperature remains the same. How is this concept of physics being applied in our daily lives? Here are some practical uses of the Ohm's Law. The first one is the speed control of conventional fans. Next, electric heaters, kettles, and other equipment. And lastly, on mobile phones and laptop chargers. All of these follow or depend on the Ohm's Law. Now, there are three formulas that we need for the Ohm's Law. These are voltage equals current multiplied by resistance, current equals voltage divided by resistance, and resistance equals voltage divided by current. V indicates the voltage, which is the electric potential difference that pushes charged electrons or the current through a conducting loop. This is measured in volts, which is represented by V. I indicates the current, which is the flow of electric charge in a circuit. It is the rate of charge flow past a given point in an electrical circuit. It is measured in amperes, which is represented by A. Lastly, R indicates the resistance, which is a measure of the opposition to current flow in an electrical circuit. It is measured in ohms. Note that the voltage and current have a direct relationship, meaning as the voltage increases, so does the current. On the other hand, they share an inverse relationship with resistance. When the voltage or the current increases, the resistance decreases. If that seems like a lot to remember, well, don't worry, because we don't need to remember all of them. All we need to do is to remember the Ohm's triangle, which looks like this. So, you just need to remember these three letters in order, V, I, R. Then, we just write those down in a triangle with V at the top and we draw a line to separate the letter. Moving on, there are two types of circuits being used in Ohm's Law. These are the series and the parallel circuits. In a series circuit, all components are connected end to end, forming a single path for current flow. In parallel circuit, all components are connected across each other, forming exactly two or more sets of electrically common points. Also, in series, the current all have the same value. Meanwhile, in parallel, the voltage all have the same value. Here's an example of series circuit, and another example of parallel circuit. The Ohm's Law theory is being applied all around us. It is one of the most fundamental laws of electrical theory. Therefore, learning this physics concept is vitally important as it allows us to analyze circuit diagrams, especially when you combine it with Kirchhoff's law, which follow on from it. So, that is it for this video. I hope that you were able to grasp all the important information on Ohm's Law. And all the best to solving the problems. Thanks for watching.